Okay, in this video, we will move on to geometric series. So I'm going to derive the formula, okay? So that is one of our I can statement. We can derive the formula for the geometric sequence. This is not sequence, this is series, right? What's the difference between sequence and series? Sequence, we have list of numbers. Series, we have sum of those numbers, okay? So you see plus sign, and that is the series. So we use the same notation for arithmetic series, geometric series, and we use capital letter S. So we are going to derive the formula here. So let's start from one example. Let's say we have a list of numbers 6, 3, 6, 12, 24, 48, like that. What's the pattern? It's multiplying by 2. It's doubled, right? So can I write this way? 3 is the first number, and then we are keep multiplying 2. So next one, 2 again, next one, 2 again. So we are raising the power. So this is the way of writing the exponential function, right? So we can write that way, and this is just the example, and we will generalize this example, okay? So if I have a certain series, which is the sum of the list of these numbers, it can be written as A1, A1 times R, A1 times R times R, and then A1 times R times R times R. So we can raise the power, and the last one will be just like A1 times R to the n minus 1. Do you remember AN equals to A1 times R to the n minus 1 power from the geometric sequence? Yep, that is just here, right? So it is a pattern, and we can write any geometric sequence using exponential form to write this way. And we are going to find the formula to find Sn, okay? Instead of adding all of this complicated one, we will derive the formula. So this is the technique how we do the formula, okay? Multiply by R. So we are going to slide a little bit to the right by multiplying R, okay? What does that mean, sliding? And I'll show you a little bit in several minutes, okay? So we multiply by R, and then one more R, and every term we have one more R, so we are raising the power. So the last one is going to be one more, so it is R to the nth power, right? And then we will subtract these two equations, top and bottom. So we subtract this. So we put negative sign in front of it, okay? That means subtraction means adding its negative. So we are going to add its negative. And now we have some magic happens. Look at this. Let's combine them, okay? Sn, subtract Rsn. That is on the left-hand side. Right-hand side, look carefully. Is there anything I can cross out? Yes, these two are like terms. It will be gone. So slide means, okay, by multiplying R, and I have the same thing created here, so this will be gone. This one, same opposite, right? Opposite with the same term. Here, opposite to each other. So every term goes away by doing this. And this one will be gone with the one term here. And last one here from the first one, this is exactly the same with its opposite sign. So this will be gone. Everything's gone. What left from the right hand side? These two terms left. So this is the technique to remove everything from one side, okay? And then let's see what left. A1 left, and then last one, A1, R to the nth power. I don't need parentheses, so I remove it, okay? Okay, that left. It's simpler, isn't it? Now let's think about factoring out. I have same Sn, so Sn will be factored out. So that is 1 minus R. 1 times this is Sn. So let's factor out A1 from the right-hand side. That is 1 minus R to the n. Okay? And now I'm driving the formula for Sn. So let's divide both sides by the quantity in front of Sn. So I will divide it, okay? A1, 1 minus Rn, that is divided by 1 minus R. I don't need parentheses, so I remove that. So that is the formula. So this is how we derive the formula, and this is explained in this place here. So that's the same formula. Sn stands for the sum up to nth term, just like arithmetic or geometric, same thing. But this formula is for only geometric series because we are using common ratio R, okay? N stands for the number of the terms, and R stands for the common ratio in the geometric sequence. So this is called geometric series formula. Some people use this, or some people use this. Either way, it's same thing. Sometimes the R is less than 1, and then we use this to have all positive numbers. Sometimes you can use R minus 1, and then you take negative outside, and you take negative outside from above, and then we can change that part so both negatives make positive. So this is still same formula. Sometimes this is convenient because we'll have positive. But anyway, we will use a calculator. So let's go with only one formula, okay? So let's go with this formula and memorize this so we can apply this on the sum of a geometric sequence. That is called the geometric series, okay?